Hello, in this video we'll be talking about the architecture of Spark. So our final goal is to understand the flow of data and of computation through our Spark data analysis pipeline. And it's very important to understand a little bit of the details of exactly what is running where in order to be able to get some familiarity on the inner workings of Spark. So let's start from the inner section and let's go from inside out looking at the architecture. So let's start from the worker node. As you remember from the lessons on MapReduce, over there you had some processes that were dedicated to the mapping stage, so the mappers, and then we had some reducers. In Spark instead we have a general executor Java virtual machine that, depending on the situation, can execute tasks related to mapping stages or reducing stages or other Spark specific workflows. This Java virtual machine is the core where all the computation is executed, and this is the interface also to the rest of the Hadoop ecosystem. So, for example, if we have the Hadoop file system, then on each worker node, some of the data will be stored locally. So, as you know, the most important point of this computing framework is to bring the computation to the data. So, Spark will send some computational jobs to be executed on the data that are already available on the machine thanks to HDFS. So we can imagine if we are running on Amazon, we have 1 terabyte of data, and this specific node has 1 gigabyte available locally. And Spark can assign for example, some mapping stage at the beginning to be run on this data, and having data read from HDFS processed in memory, and then the results stored as one RDD. The actual computation, if you are running on using the Scala interface or the Java interface, is running straight into the executor Java virtual machine. Instead, if you are using PySpark, then there will be several Python processes, generally 1 per task, but you can configure it depending on your application, are connected to the Java virtual machine, and data are shipped from the Java virtual machine to Python for processing. Then, of course, we will have many of these nodes. We can have hundreds or thousands of those, and it's important to have a system that can automatically manage provisioning and restarting of these nodes, and this system is called the cluster manager. And Spark supports mainly two interfaces for cluster management. One is Yarn, which is the Hadoop cluster manager, and the other is a standalone mode. The standalone mode means that there is a special Spark process that takes care of restarting nodes that are failing, of starting nodes at the beginning of the computation, and instead using the Yarn interface has an advantage because we can use this in conjunction with Hadoop MapReduce and other Hadoop, and we can use the same cluster managed by Yarn with Hadoop MapReduce or with Spark. And finally, we have our interface with the cluster. The interface is the driver program, and depending on the configuration, this can run on another node on Amazon or can even run on our laptop. On the driver program, we have a Java virtual machine that has a Spark context, which is an object, which is the gateway for us to connect to our Spark instance and submit jobs. We can either submit jobs in batch mode, which with Spark submit. So we basically prepare our job, we write a Python or a Scala program, and then we call job submit, we call Spark submit with this program, and we send it for execution in batch mode, and then we wait for the result. Or we can open the Spark shell, the Scala or the Python one, and interact in real time with our data inside the shell. And in the shell we have access to this Spark context with the variable SC, and we can call this variable to read data into our Spark instance and to write down our processing pipeline. And finally, let's see how this setup works on the Cloudera VM. In the Cloudera VM, we are using Spark in standalone mode, and everything, of course, is running locally, so it's a single machine. And on the same machine, we have the executor JVM, our one single PySpark process, and then our driver program on the same machine. Instead, if, for example, we run on Amazon EMR, now Elastic MapReduce from Amazon is supporting Spark natively, so you can configure through the web interface how many instances you want to run, which kind of instances, how much memory, and so on. And then Amazon EMR is going to automatically run Yarn and spawn all those instances and prepare them for being executed with Spark. And also on the what you see on the right of the slides, these are running on EC2 instances, and on the left the driver program and the yarn process are running on the master node, so which is just one specific instance of the group that you reserved for this application. And then you can SSH into the master node, and from there you can interact with your Spark cluster. And so you can either use Spark submit for batch jobs, or you can open a Spark shell for interactive work with your data. In the next video, we will be talking about the key element of Spark, which is transformation, and the data workflow built upon them.